Hi, my second last try now, try now 30. I think this one you can find on page, I think it's 499. Okay, similar like what we did before. They give you a curve and then they say you must show the derivative of that curve. So let's see. Um, if I was to use GeoGebra, let's see quickly. I'm going to do this. So I'm going to input the equation of the curve. The curve is 3x squared, 3x squared minus 4xy. Is this, things that looks like ellipses and so on, plus 2y squared. So that's 2y squared, 2y squared minus 6. Because let's say y equals to, so y equals to, that's what I have. Okay, that's what I have. The reason why I thought of drawing this is, and it's exactly the same thing that I have done. Yeah, it's exactly the same thing that I have done. Okay, they say the coordinates, find the coordinates of each of the points on the curve where the tangent is parallel to the x-axis. Now, whenever that is the case, something that's parallel to the x-axis is something like that. So, okay, my line is not so straight, but I think you get the idea. So what they are looking for is the values of x, and clearly you will agree to me that it's somewhere between -1 and -2, and somehow below -2 for the value of y, and somewhere between 2 and 3, and somewhere close to 4. Okay, if you were to do that. So it might be that the way the question is set up, that those coordinates of the points on the curve where the tangent is parallel to the x-axis, tangent is parallel to the x-axis, because that implies dy dx is equal to 0. So let us see. In fact, let's just go back to the software and let's see um, if we can do it as well. So what if I say, what if I say I edit view, maybe, and I will take the computer um, algebra system, and what I want to do is I want to solve the derivative of this equation. Or we can actually do this using the software. I can say, okay, derivative, implicit derivative of that function, of the function y. Okay, so that is f of x. Let's type it in there, 3x square minus 4x. I'm just playing around, minus 4xy plus 2y square. So you can see it's doing it, minus 6. And this 3x minus 2y, 2x minus 2y, that is what we are supposed to get. Is it not so? That's what we are supposed to get if you look at it nicely. Okay, good. So I just use the software to show you. Now, I would want to solve to see what this is. So I'm going to say solve this equation. So let's just say solve this equation, and I'm going to type that whole equation. Okay, so this equation, it's 3x minus 2y divided by, okay, so it's 3x divided by, let me go back, minus 2y over 2x, so I'm taking this, minus 2. There you go. Right. Just remember this. We are going to get something like this. So first, I've used the software and I showed you how the function looked like, or how the equation of this looks like. Okay, that little oval type of thing. So, and then I also showed you how to find the implicit derivative, which we are going to do because we are supposed to get to this. And then I also solved it. But so what it does is similar like the one before, try not 29, where we had an x value, and we're going to take this and substitute it back into the original function to get the y values. All right, so let's go to the question and then see. So they say, show first of all dy dx is equal to that. So let's do that over here. So there is a lot happening here because you also have the product rule that you have to apply over here. So you have to be a bit careful with this one so you don't end up making mistakes. So it's d by dx of, let me just write it, 3x squared minus 4xy plus 2y squared minus 6 is equal to d by dx of 0. Ah, I made it. Okay, right. Maybe let me just write it over here. So I have d by dx let's take 3x squared minus d by dx, let's take 4xy together here, plus d by dx of 2y squared minus d by dx of 6 equals d by dx of 0. Okay, let's continue and see. So I have, this is nothing but 6x minus, this is going to be, keep the first 4x times the derivative of the second one, which is just 1. Then I have dy dx, plus keep the second times the derivative of the first, plus 4y dy dx equals to 0, because this is also 0 and the other side is equal to 0. So definitely no need for me to say minus 0. Good, let's just clean it up. So I've got 6x minus 4x dy dx. Just be careful of this negative. It kind of changes the sign when you do this negative distribution. Just be very careful here. Okay, it's going to change the sign of everything inside the bracket. So that negative and that one there over there becomes a negative 4y plus 4y dy dx is equal to 0. So at the end of the day, I have negative 4x minus, or plus rather, 4y. This one is with dy dx, and then I'm going to have minus 6x plus 4y on the other side of the equation. Then dy dx, therefore, is equal to minus 6x plus 4y all over minus 4x plus 4y. Okay, so as far as I'm concerned there, I'm done, but it's not looking like the one. So there's something I need to do. So let me just grab it so that I can show you. So if we have to take that, just take that. Okay, So they say we should show that, and in order to do that from here, I believe we have to multiply by -2. Multiply by -2. Each of the terms should be multiplied by -2. And if you, is it multiplied? No, I think it's divided, okay? That's divided because you don't want to make it bigger, we want to reduce it. So we divide each term by -2. When you do that, you're going to get 3x, -2 here, minus 2y. When you divide a negative into a negative, you're going to get 2x, and here, minus 2y. This is dy dx. Surely it looks exactly like what they have told us there that we are supposed to do. Now, there is a B part to this question. So let's go grab that B part. It says find the coordinates of each of the points on the curve where the tangent, just bring the whole thing there. I'm going to put it here. Find the coordinates of each of the points on the curve where the tangent is parallel to the x-axis. Right. When that is the case, when something is parallel to the x-axis, this here, when something is parallel to the x-axis, the gradient, because the equation of the x-axis is 0, so dy dx should equal to 0. Okay, so that means we are going to set our gradient, which was 3x minus 2y, remember, over 2x minus 2y. We're going to let it equal to 0 and multiply that whole denominator by that 0. Will just leave us with 3x minus 2y is equal to 0. Here you have got 3x is equal to 2y. Then dividing throughout by 3 will provide us a point. We'll get that x is equal to 2 over 3y. Now this is the value of x. And remember from my software, I had it. X equals to 2 over 3y. Can you see that? X equals to 2 over 3y. X equals to 2 over 3y. Now, we have the value of x. We need the corresponding value of y. So we'll have to take this again and substitute it into the original equation. So let me just bring that equation down because we have to do some substitution and find the coordinates. So let's grab it. So there's the equation, and we are going to have it here. I'm looking for the coordinates. So everywhere where I have an x, everywhere on an x, I'm going to substitute it by, so we have an x over here, and x there, I'm going to substitute it by this value. Does that make sense to you? Right, so that's 3 in brackets squared minus 4 in brackets, that should multiply by y as well, plus 2y squared minus 6 is equal to 0. So let's bring what we grabbed. So that's 2 over 3y. That will be 2 over 3y. Let's keep on multiplying and see. This is ordinary level work. There's no calculus is done. So we have got 3 times 4 over 9 y squared. That's 2 squared is 4, 3 squared is 9, y squared. Minus, I'm going to have, maybe first I multiply, I've got 8 over 3 y. There's still a y inside. In fact, I can actually multiply that times that. That's going to be y squared as well. Okay, y times y. We together so far. Plus another y squared minus 6 is equal to 0. Let's just clean up what we have. Okay, 3 goes in here 3 times, so that's 4 over 3 y squared minus 8 over 3 y squared plus 2 y squared minus 6 is equal to 0. Okay, 3 goes there 3 times and so on. Good. Let me just grab a calculator because I do not want to make a mistake here. So let's just add those coefficients. So I'm going to have 4 over 3 minus 8 over 3 plus 2. We get 2 over 3. There we go. So this gives us 2 over 3 y squared minus 6 is equal to 0. Now let's multiply by 3 to get rid of that fraction. So we're going to multiply throughout by 3. That's going to leave this one of 2y squared, and 3 times that, 3 times 6 is 18 is equal to 0. Okay, then this is obviously taking out a common factor. Okay, this is 2 y squared minus 9 is equal to 0. Well, divide throughout by 0 by 2. That's just going to leave you with y squared minus 9 is equal to 0. This is the difference of 2 squared, if you still remember. So this implies that our value of y is positive and negative 3. That's what it implies. Okay, so let's quickly go grab our x. Our x I could write it down, but I'm a little bit lazy. So I'm going to grab the x in order for us to find the corresponding x values. Maybe I must append the page. Just append the page. I've used too many. Okay. What do we know? We know that the values of y is equal to positive or negative 3. So when y equals to 3, x will be 2 over 3 times 3, x will equals to 2. When y equals to negative 3, x will be 2 over 3 times negative 3, which is minus 2. So what do we have? We have our coordinates for x and y are x is 2 when y is 3, and x is negative 2 when y is negative 3. Ultimately, this is the solution to that. I just want to look at my diagram just to see if really it makes sense. So if I go get my, well, the work is done as far as that is concerned. I'm just playing a bit around with particular values here. So let's just snapshot this thing here and see what happens, if it really makes sense. They say the tangent, so that they say x is 2 and y is 3. Of course, you can see it doesn't really look like there's where it turns. The gradient is going to be those values are 2 and 3. Of course, so the diagrams can be a bit deceiving. Okay. Anyway, stand by for try now 31, which is I'm only doing question 2, try now 31, and I think I would have done justice to your work on implicit differentiation. And then tomorrow you stand by, or later I'm going to add then questions on implicit differentiation, and then in the week, another day or so, Monday, I'm going to do a few questions on just applications of differentiation. And then when we're done with that, so come Wednesday, I'm going to go for another 2 weeks, and I'm going to upload integration. So we are going to do anti-differentiation, that is integration. So towards the end of the month, I should be done with integration, doing quite a lot of your try nows in your textbook and as well as the question paper so that you can see. Okay.